Welcome. In today's video, we're going to derive the expected value and variance of a Bernoulli distribution. To begin with, let us first remind ourselves about the probability mass function of a Bernoulli distribution. So, if x has a Bernoulli distribution with parameter p, where the p is the probability of success, then the probability mass function, or the probability, or the PMF of x, is given by the following. And we're going to have it in two expressions for the purposes of this. Sometimes you might see it written as the probability of x is equal to x is equal to p if x is equal to 1, and 1 minus p if x is equal to 0. Or alternatively, we can write it in the form p to the power of x, 1 minus p to the power of 1 minus x, where x takes values of either 0 or 1. And in case you want to confirm, if you plug a value of x is equal to 1 in this expression, what happens is you get p to the 1, which just becomes p, and then you get 1 minus 1 here, which gives you 0, and anything to the power of 0 becomes 1, so that whole expression there collapses to 0, so you're just left with p. And equally, if you plug in 0 here, and you get p to the 0, that expression collapses to 1, and then this becomes 1 minus 0 in the power, and so the whole expression just becomes 1 minus p, and that mirrors the top function. I'm going to prefer to use this function here because I think it's easier to express, at least when you're doing expressions of expectation and variance. So now that we've established that, we can use our definition of expectation for a discrete random variable, and simply the definition of expectation is equal to the sum across all x of x multiplied by the probability of x equaling x. And in this case, we only have two possible values of x, or our support. It's from x equals 0 to the power of 1. So that becomes our terminals of our summation. Then we've still got our x times, and now I'm going to stick in my definition, or my PMF in the expression here, and that becomes p to the x, 1 minus p to the 1 minus x. Plugging in our values of x of 0 and 1, what we get is 0 times p to the 0, 1 minus p of 1 minus 0, plus 1 times p to the 1, 1 minus p to the 1 minus 1. The first expression here is simply going to collapse to 0 because we're multiplying by 0 at the front, so that's easy. Then our expression here, we've got 1 times something, so that's just, I guess, disappears. You can think of it. You've got p to the 1 here, so that's plus 1 times p. And then we have an expression 1 minus p to the 0, and we know that anything to the power of 0 is 1, so that collapses to 1. And then finally, simplifying down, we get to a value of p. To derive the variance of x, or to get to the variance of x, we first need to establish the expected value of the second moment of x, or the expected value of x squared. So let's do that now. So the expected value of x squared, by definition for a discrete random variable, is the sum across all x of x squared multiplied by the probability mass function. Again, our terminals are going to be from x equals 0 to 1. we've got our value of x squared, and again we're going to plug in the probability mass function p to the x 1 minus p to the 1 minus x here. And again, what we're going to do is we're going to plug in our values, so that becomes 0 squared times p to the 0, 1 minus p to the 1 minus 0, plus 1 squared times p to the 1, 1 minus p to the 1 minus 1 here at the back. And all in all, we actually are going to get to the same result. This first part of the equation simply simplifies to 0. And the second part of the equation looks very similar to the first part that we had up the top. The only difference is instead we have a 1 at the front, now we have a 1 squared. So again, this will just collapse to p. And I'm going to go straight there. Now that we have the expectation of x and the expectation of x squared, we can derive the variance. And we know that the definition of the variance, or the computational version that we're going to use here, is the expected value of x squared minus the expected value of x all squared. Now, plugging in our values that we had, the expected value of x squared we derived as p. So we're going to put that through, minus our expected value of x was also p up the top here, so we're going to put that p squared here. And then as a final step here, what we're going to do is we're going to factor out p. So we've got p, 1 minus p, and we've derived our formula for the expected value of x and the variance of x. Thank you for watching. Hope to see you in the next video.